This video will answer the question, what is a logarithm? I got some different colored pens here, I got some graph paper, we are ready to go. We're going to start off with the exponential function y equals 2 to the x power. This is called an exponential function because the variable is in the exponent position. So I'm going to label exponential equation. All right. This has an input of x and an output of y. The input are all variables, or not variables, but the inputs are all exponents. So I'm going to make a little table here. And 0. Awesome. 2 to the 0 power is 1. Anything to the 0 power is 1. 2 to the first power is 2, so I'm putting 1 in there, 2 to the first. And then 2 to the second is 4. And then 2 to the third, so 2 to the third power is now 8 because it's 2 times 2 times 2. Let's throw a couple of negatives in there because negative numbers for exponents do not mean negative number, they mean fraction. So 2 to the negative 1 would be 2 to the negative 1, cross the line, change the sign, it'd be 1 over 2. So it's a half. And then negative 2 would be 2 to the negative 2, which would be 1 over 2 squared, which is 1/4. And then negative 3, 2 to the negative 3 would be 1 over 2 cubed, which is 1 over 8. So I have all the way from 1/8 to 8, which is kind of cool because if you think about these, those are opposites of each other, 3 and negative 3, the opposite side of 0, and then 1/8 and 8 are reciprocals of each other. So that's kind of a cool connection there. All right. Now, this graph is going to happen on this graph paper here. So I'm going to take these points and graph them out. 0, 1, and 1, 2, and 3, 8. So this rises really fast, which is why it's exponential. So it's 0, 1, 1, 2, 2, 4. Oops. Well, that's unfortunate. I didn't go over enough spaces, did I? Well, this is the way it goes. My videos are all one take, so we'll fix it as we go. Plus, maybe I've had too much caffeine today. I'm going too fast. So 0, 1, 1, 2, 2, 4, 1, 2, 3, 4, and then 3, 8 would be up here. All right. So I got off by a column. It can happen to the best of us. So now I'm looking for my whiteout. Where's my whiteout? I've lost my white. Oh, it's right here in front of me. If it was like a little bug, it would have bit me. So we're going to kill that point right there. All right. Go away. Go away. I can even fix it and make it better. So I'll put the line back in. Now everybody should be happy, right? So 0, 1, 1, 2, 2, 4, and then 3, 8. And then over here, we're going to do negative 1, a half, negative 2, a fourth, and then negative 3, an eighth. So this thing grows really fast. That's why we call it it's, you know, and you hear about growing something exponentially. And then it comes in here, and it approaches but actually never crosses over the x-axis. So there's the exponential function y equals 2 to the x. Now, switch x and y. The opposite of exponential is some other function. So to figure out what that function is, we switch x and y, solve for y. That's how you find the inverse. You make the input the output and the output the input. So let's go back to the black paper here, or the white paper with the black writing on it. So now I'm going to switch and make it x equals 2 to the y. So that would be the inverse of the exponential equation. Well, guess what? The inverse of the exponential equation is what a log is. So we switch x and y, we solve for y. So how do I solve this for y? I have no way to solve for y. I don't know how to solve for y. So what we do is we rearrange this with a new name, and that's the logarithmic function. We abbreviate it log. So we go y is equal to log base 2 of x. And that is where this is born. The logarithm is the opposite, the inverse of exponential. So this position right here is the base. So the base always fits there. The exponent it always goes here. So the exponent goes there, and then the answer is right there. So it's base, answer, exponent. And the rearrangement of the inverse by switching x and y is a log. That's how we we needed a function to do that. So mathematicians created the log function to solve this for y. So we can get y by itself again, like if you've ever done inverses before. So guess what? I have a table of values for this that work with this. So all I have to do is just switch these over here. So I got 1, 0, 2, 1. So log base 2 of 1 is 0, log base 2 of 2 is 1, and log base 2 of 4 would be 2. And how am I getting these? Well, I'm just switching the x and y, switch x and y. And then all the fractions come in. 1/2 would be -1, 1/4 would be -2, make my 1 better here, and then 1/8 would be -3. So that is the inverse of this table here. These tables are inverses of each other. And the equations are inverses of each other. So here's the exponential equation, there's the log equation. It's still a 2, an x, and a y, but it's switched around differently. So now I'm going to graph this. So here we go. Hopefully I can graph this better than I did with the last one. So here's all my points right here, and I'm going to graph. This would be 1, 0, 2, 1, and then 4 up 2, and then 8 up 3. So see how it curves, with the mirror image of the other, the original function. And then we got a fractions in here, half down -1, a quarter down -2, and an eighth down -3. And you just kind of squeeze it in there as best you can, and it won't cross this way. So this is y is equal to log base 2 of x. So that's what a logarithm is. It's the inverse, the switching of x and y. It's the inverse of an exponential equation. We really need this exponential equation inverse deal. One of the things that we can do, let me pause this for a second. Okay, the log on the calculator that we see right here is log base 10. That's the standard log. So we have 10, or log of 10, enter is 1. Let's see if we can see a pattern here. Log of 100 is equal to 2. And log of 1,000, you guessed it, it's equal to 3. And log of 10,000, I think I got enough zeros there, yep, is equal to 4. So it appears that it's counting zeros. So let me write this down and it'll make sense. So the one of the things that I typed in was log of 100 was equal to 2. So this will make the connection back to how this all works, and how it's related to the exponential equation and all that kind of stuff. So right now we know that a logarithm, right, the switching of x and y and solving for y, the function that does that is log. So you can't really solve this. We'd have no way of solving for y here. So we switched x and y. How do you solve for y? You use this new function called log, and it just rearranges those things, gets y by itself. So here's this connection again. Log on the calculator with nothing there means log base 10. So you can kind of see the connection here between the exponential and the log. So 10 to the second power is 100. 10 to the second power is 100. So this is the base. This is the answer. And this is the exponent. So one of my students a few years ago said that logarithms are your bae. Base, answer, exponent. 10 squared is 100. So you really don't need anything in the world. You don't need a significant other. You have logarithms. Logarithms are your base, answer, exponent. This is really an important connection. If you can remember nothing else, the connection between the log version and the exponent version, 10 squared is equal to 100. So making the connection between the two is very, very, very important.